At a modern farm equipment auction in the American Midwest, something strange is happening. A 40-year-old John Deere 4440 rolls onto the block, and the bidding does not treat it like an antique. It sells for a massive premium, often rivaling the price of newer equipment. The reason is not nostalgia, it is survival. The 466 cubic inch diesel engine inside the 4440 predates Tier 4 emission standards. It requires no diesel exhaust fluid, has no complex particulate filters, and crucially contains no proprietary engine control unit. If a modern John Deere throws a digital error code in the middle of the harvest, the machine stops. The farmer cannot fix it with a wrench in the dirt. They must wait for a dealer technician with an authorized laptop. The older mechanical engine has become an economic weapon against the modern service network. But the real story of the John Deere engine is not only the story of a rural bidding war. It is the story of how America powered its farms, how it learned to trust a piece of iron, and what happened when that mechanical trust was permanently replaced by a software lock. Every week, we tell the stories of American engines, factories, machines, and industrial names that once taught the country what power sounded like, and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place. In Waterloo, Iowa, in 1918, the story of how American agriculture surrendered to the internal combustion engine does not begin with an app, a software lock, or an emissions mandate. It begins with raw iron, heavy fuel, and a mechanical problem that had to be solved in the dirt. In 1918, the American farm was caught in a brutal transition. World War I was pulling young labor away from the fields, and the Great Plains demanded more mechanical power to compensate. Steam engines existed, but they were massive, heavy, prone to getting stuck in soft soil, and required a dedicated operator just to shovel coal or wood and monitor the boiler pressure. Deere & Company, based in Moline, Illinois, was already an empire built on the steel plow. But they knew that the future of the American farm would not be pulled by horses. To survive, they needed an engine. Rather than design a power system from scratch, in 1918, John Deere purchased the Waterloo Gasoline Engine Company in Waterloo, Iowa. It was a strategic acquisition that brought them a functional, kerosene-burning tractor known as the Waterloo Boy. But more importantly, the buyout gave John Deere a manufacturing footprint in Iowa and a foundational engineering philosophy that would define the company for the next 40 years. The horizontal two-cylinder engine. At the time, the engineering problem of the American farm was unlike anything in the automotive world. A passenger car engine might run at 20% of its maximum capacity while cruising down a paved road. A tractor engine operates at maximum load, dragging heavy steel plows through dense, baked clay, enveloped in a constant cloud of abrasive dust from sunrise to sunset. If the engine failed, the planting was delayed. If the planting was delayed, the crop was lost. The machine had to be absolutely relentless. The engineering solution that emerged from the Waterloo foundry was a masterpiece of industrial simplicity. In 1923, John Deere introduced the Model D, a machine that would cement the company's reputation across the American Midwest. At the heart of the Model D was a massive two-cylinder engine, a power plant that uses exactly two pistons to generate power, which in this era meant two oversized cylinders firing at a slow, deliberate pace. Instead of building an engine with 4 or 6 smaller cylinders, which would require more moving parts, more valves, and more bearings, John Deere's engineers reasoned that fewer parts meant fewer failures. The block was cast iron. The two massive pistons were laid flat in a horizontal orientation. The early Model D engine displaced 465 cubic inches, a displacement larger than most modern V8 truck engines, but divided entirely between just two cylinders. This engine was not built for speed. It operated at a redline of around 800 to 900 RPM. What it produced was raw torque, twisting force, often felt as the pulling strength of an engine. In the agricultural world, torque is the difference between a tractor slicing through hardpan soil and one stalling in the field. When tested at the famous Nebraska tractor tests, a strict state-run evaluation program designed to prove whether agricultural equipment actually delivered the power manufacturers claimed, the early Model D proved it could deliver 15 drawbar horsepower. Drawbar horsepower is a measurement of the actual pulling force a machine can apply to an implement in the dirt, which is a far more punishing metric than engine horsepower measured on a stand. It also delivered over 30 belt horsepower, the power delivered to a flat belt pulley, used to run stationary farm equipment like threshing machines and sawmills. To keep the engine alive in hostile environments, the design aggressively eliminated weak points. It utilized a magneto, an electrical generator that provides ignition spark entirely on its own, meaning the tractor did not need an unreliable battery to run. It used thermosiphon cooling, a liquid cooling system that relies on the natural upward flow of hot water and downward flow of cool water, eliminating the need for a mechanical water pump that could break. Because the engine was so simple, it could run on cheap low-grade fuels like kerosene or tractor distillate after being started on a small tank of gasoline. And because of its unique firing order, the exhaust produced a distinct, rhythmic popping noise. Across the American Midwest, John Deere tractors earned the nickname popping Johnnies. That sound became an auditory gauge for the American farmer. A trained operator could listen to the cadence of the exhaust from across a field and know exactly how hard the engine was pulling, whether the plow had hit a rock or if the fuel mixture was running lean. The sound of a two-cylinder John Deere was the sound of a harvest staying on schedule. But the true genius of the Waterloo two-cylinder engine was not just in how it ran, it was in how it was repaired. This was an engine designed for a rural reality where the nearest mechanic might be a day's wagon ride away. If a valve needed adjusting or a piston ring needed replacing, the farmer could often do it themselves, right in the field or inside a drafty machine shed, using basic hand tools. The engine block featured large inspection covers. The parts were heavy but accessible. John Deere provided detailed oil-stained service manuals that treated the farmer not merely as a consumer, but as a competent mechanical partner. The relationship between the manufacturer, the machine, and the operator was entirely transparent. The farmer owned the iron, understood the mechanics, and held the ultimate authority over whether the engine lived or died. The two-cylinder engine had conquered the American farm, but as the scale of agriculture grew, the fields began to demand a kind of power that two-pounding cylinders could no longer provide. By the end of the 1950s, the American farm had changed. The small 40-acre family plot was rapidly expanding into operations covering hundreds or thousands of acres. Tractors had to pull wider plows, heavier discs, and larger planters. But there is a brutal physical limit to how much power you can extract from just two cylinders. As engineers at the Waterloo factory tried to squeeze more horsepower out of the traditional layout, the sheer size of the pistons created violent vibrations. The two-cylinder engine had reached the end of its mechanical evolution. If it got any bigger, it threatened to shake the tractor and the farmer to pieces. The turning point arrived in August 1960 in Dallas, Texas. John Deere chartered commercial airliners to fly more than 5,000 dealers to a massive, highly secretive unveiling. The event was called Deere Day in Dallas. Inside the Dallas Memorial Auditorium, the company shocked its own service network by announcing the new generation of power. The beloved Johnny Popper was dead. In its place, John Deere introduced a completely new line of multi-cylinder machines. The true breakthrough of this new era arrived in 1963 with the introduction of the John Deere 4020, a machine that would go on to become the most popular tractor of its time. At the heart of the 4020 was a completely new 404 cubic inch diesel engine. A diesel engine, an engine that ignites fuel by compressing air until it becomes hot enough to burn diesel fuel, rather than using a spark plug, was not a new invention. But John Deere's execution of the 404 cubic inch block turned it into the definitive agricultural standard. The engine was a straight six, a six-cylinder engine arranged in one continuous line. This layout provided perfect primary and secondary mechanical balance. Instead of the violent, rhythmic shaking of the old two-cylinder blocks, the straight six delivered smooth, continuous rotational force. The 404 number referred to its displacement, the total volume swept by the pistons inside the cylinders. At 404 cubic inches, this engine possessed massive lung capacity. It was naturally aspirated, meaning it drew in air at atmospheric pressure without a turbocharger. relying entirely on its heavy internal geometry to create power. When evaluated at the Nebraska tractor tests, the diesel 4820 delivered over 90 horsepower at the power takeoff. Horsepower, a measurement of how quickly an engine can do work, only told half the story. The real triumph was its torque. The 404 engine had a torque curve so broad and forgiving that a farmer could drop the plow into heavy, wet Midwestern clay, watch the engine RPM drag down, and hear the governor open up the fuel rack. The engine would bear down, emit a thick puff of black smoke, and simply pull through without stalling. But a great block means nothing if it cannot be kept alive. The genius of the 404 cubic inch diesel was how it was integrated into the American Rural Service Network. John Deere designed the block with wet cylinder liners. Instead of the piston riding directly against the cast iron of the engine block, it rode inside a replaceable steel sleeve surrounded by engine coolant. This specific engineering choice was a profound sign of respect for the farm repair culture. It meant that when the engine finally wore out after 10,000 hours of dragging steel through the dirt, the farmer did not have to remove the entire block and send it to a machine shop in a distant city. They could park the tractor in a machine shed, drain the fluids, drop the heavy cast iron oil pan, pull the cylinder head, and push the old pistons and liners out from the bottom. An overhaul, a major service process where an engine is taken apart, inspected, and rebuilt to operating standards, could be completed by a local mechanic or a mechanically inclined farmer using a standard set of wrenches and a factory rebuild kit. This engine design locked in John Deere's absolute dominance because it was backed by an unrivaled system. The engine was just the iron. The system was the local John Deere dealer. By the 1960s, almost every rural county in the American Midwest had a dealership with a green and yellow sign out front. Behind the parts counter were rows of meticulously organized bins containing every gasket, bearing, fuel injector, and connecting rod a 404 engine could ever need. If a tractor broke down during the crucial weeks of the fall harvest, the dealer network ensured the machine was running again by the next morning. The 40-20 and its 404 engine changed the auditory landscape of rural America. The slow, popping rhythm of the old kerosene burners was replaced by the smooth, heavy, continuous hum of diesel power. From the wheat fields of Kansas to the corn rows of Iowa, the multi-cylinder John Deere diesel became the baseline definition of reliability. It was not a disposable tool, it was a generational asset. The 40-20 proved that John Deere could build a modern diesel, but the true test of the American farm was whether an engine could run not just for a season, but for a generation. By the 1970s, American agriculture was operating on a scale that previous generations could not have imagined. The pressure on the American farmer was no longer just about survival, it was about sheer volume. The fields of the Great Plains and the Midwest were consolidating into massive industrial operations. Equipment had to run longer, pull wider implements, and do it faster. The multi-cylinder diesel engine had already proven it could survive the dirt. Now it had to dominate the horizon. In 1977, John Deere introduced a machine that would become the absolute peak of the mechanical power era, the 4440. If the 40-20 was the breakthrough, the 4440 was the empire fully realized. Beneath the hood of the 4440 sat a massive 466 cubic inch inline-six diesel engine. But unlike its naturally aspirated predecessors, this engine was breathing differently. It was equipped with a turbocharger, a device driven by exhaust gases that forces more air into the engine, allowing it to burn more fuel and create more power without increasing the physical size of the engine block. When the 4440 was tested at the Nebraska tractor tests, it delivered over 130 horsepower at the power takeoff. But again, horsepower was just a number on a specification sheet. The reality of the 466 cubic inch block was its relentless, twisting torque. A farmer could drag a massive chisel plow through dense, compacted soil, and when the implements hit a tough patch of clay, the turbocharger would spool, emitting a distinct, high-pitched whine over the deep exhaust note, and the engine would simply bear down and pull. It did not stall. It did not quit. In an America where an engine could decide whether a crop was harvested before the frost, a family farm survived a low-yield season, or a rural town maintained its economic heartbeat, power was not an abstraction. It was iron, fuel, labor, heat, sound, repair, and trust. The 4440 and its 466 cubic inch engine represented the golden age of American farm repair culture. This was the era when the farmer was completely insulated from the elements, but not isolated from the machine. John Deere had introduced the Sound Guard body, a curved, rubber-isolated cab that protected the operator from the deafening roar of the diesel engine and the choking dust of the field. Inside the cab, the farmer could listen to the radio and work in air-conditioned comfort. But beneath the floorboards, the relationship with the iron remained entirely mechanical. There were no hidden digital firewalls. The fuel system was governed by a mechanical injection pump, a complex but entirely physical device that metered out diesel fuel based on the physical position of the throttle and the centrifugal force of internal governor weights. If the pump began to fail, a trained diesel mechanic at the local John Deere dealership could take it apart on a clean workbench, replace the worn springs and plungers, calibrate it on a test stand, and bolt it back onto the block. The farmer owned the tractor, but more importantly, the farmer owned the right to understand it. Between 1977 and 1982, John Deere built over 90,000 4440 tractors. The 466 cubic inch engine became the ubiquitous heartbeat of the American harvest. In small towns across Iowa, Nebraska, and Kansas, the local John Deere dealer was often the largest and most important business on Main Street. The parts counter was a social hub, a place where farmers gathered on rainy mornings to buy oil filters, hydraulic hoses, and replacement cylinder liners. The brand was no longer just a manufacturer of tools. It was the infrastructure of rural survival. The iron was perfect, the dealers were trusted, and the system was whole. But this mechanical empire was about to reach its physical limit. The success of the 4440 tractor was only a fraction of the story. The true scale of John Deere's engine empire in the late 1970s and 1980s was found in the sheer omnipresence of the 400 series engine family across the American landscape. The Waterloo factory was no longer just building tractor engines. It was casting the mechanical foundation for an entire agricultural and industrial ecosystem. The 466 cubic inch inline-six diesel did not stay confined to the 4440. John Deere engineered it as a modular platform. If a farmer needed to pull even heavier loads, they bought the 4640 or the massive 4840, which utilized an intercooled version of the exact same 466 block. An intercooler, a mechanical heat exchanger that cools the compressed air coming out of the turbocharger before it enters the engine, allowed the engine to burn even more fuel and safely produce upwards of 180 horsepower without melting the pistons. But the real brilliance of the 466 block was its cross-platform domination. When the fall harvest arrived on the Great Plains, the same engine architecture that had pulled the planters in the spring was now powering the massive Titan Series combines, like the legendary John Deere 7720 and 8820. These were towering, complex machines that relied on the 466 engine to not only propel thousands of pounds of steel through muddy fields, but to simultaneously power the spinning threshing cylinders, straw walkers, and augers that separated the grain from the chaff. A combine engine operates in the worst possible conditions: suffocating dust, high ambient heat, and a constant, unyielding maximum load. The 466 ran flawlessly. This part's commonality was a profound advantage for the rural American service network. A farmer running a 40 tractor, an 8820 combine, and a stationary John Deere irrigation pump drawing water from the Ogallala Aquifer in Texas all relied on the exact same engine family. That meant they only needed to stock one type of oil filter, one type of fuel injector, and one set of engine bearings in their machine shed. The local John Deere dealer did not have to carry an infinite variety of parts. They just needed to keep the 400 series bins fully stocked. By the early 1980s, the engine had achieved something rare in American manufacturing. It had become financial collateral. Agricultural lenders and rural bankers understood that a John Deere tractor, powered by a mechanical 466 engine, was a nearly liquid asset. If a farm went bankrupt, the tractor would easily sell at auction because neighboring farmers knew the engine could simply be rebuilt and returned to the field. The block was cast so heavily, and the rotating assembly was balanced so well that it was not uncommon for these engines to log 10, 15, or even 20,000 hours of heavy labor before requiring a complete overhaul. In a machine shop in Nebraska, a mechanic could tear down a 466, drop the block into a hot tank to strip away the baked-on grease, measure the crankshaft journals with a micrometer, install fresh wet liners and piston rings, and bolt the cylinder head back down with absolute certainty that the engine was good for another 20 years. There was no proprietary software to flash. There were no digital handshakes required to make the fuel injectors talk to the dashboard. The entire system ran on the undeniable laws of mechanical physics: compression, fuel, and air. This era forged an unbreakable psychological bond between the American farmer and the Waterloo engine line. The green and yellow paint meant something specific. It meant that a family's livelihood was secured by a piece of iron that they could touch, hear, understand, and repair. The engine had conquered the dirt, outlasted the competition, and taught America to trust a sound. The mechanical system was flawless, but the engine was about to collide with a force it could not outpull, a changing environmental rulebook that would fundamentally alter what an engine was legally allowed to be. The first crack in John Deere's mechanical empire did not happen because an engine failed in the dirt. It did not happen because a connecting rod broke or a cylinder head cracked under the strain of a heavy harvest. The first crack was almost invisible. It happened because of a shift in a government rulebook that changed how American air was legally measured. For decades, the black smoke that poured from the exhaust stack of a John Deere diesel under heavy load was considered a symbol of work. It was the visual proof of torque. But in 1996, the Environmental Protection Agency introduced Tier 1 off-highway emission standards. This was the arrival of Force 3: regulation, emissions, fuel economy, and certification. The American farm engine was no longer just an agricultural tool. It was an environmental variable. To meet these new regulations, the engine could no longer rely on a purely mechanical fuel injection system, a completely physical setup that sprayed fuel into the engine based on springs, weights, and throttle position. Mechanical pumps were brilliant, rugged, and completely understandable to a farmer, but they were not perfectly precise. They occasionally delivered more fuel than the engine could burn, resulting in soot. To clean up the exhaust, John Deere had to control the combustion cycle with digital absolute precision. The solution was the Engine Control Unit, or ECU. The ECU is a computerized brain bolted directly to the engine block, designed to monitor temperature, air pressure, throttle position, and engine speed, and then calculate the exact microsecond to fire the fuel injectors. When John Deere rolled out its new PowerTech engine family in the late 1990s, the blocks were still painted green, the iron was still cast heavily, and the tractors were more powerful and fuel efficient than ever before. But when an American farmer took delivery of a new 8000 series tractor, parked it in the machine shed, and opened the hood, they were looking at a fundamentally different machine. Woven through the cast iron was a complex labyrinth of wiring harnesses. Placed at critical points along the block were electronic sensors. The mechanical linkage that once connected the farmer's right foot directly to the fuel pump was gone, replaced by a wire that sent an electrical request to a computer, which then decided how much power the engine was allowed to make. This was a profound shift in American farm repair culture. For half a century, a farmer could diagnose a John Deere engine with their eyes and ears. If a valve was out of adjustment, it tapped. If a mechanical injector was failing, the engine misfired and shook. If the fuel filter was clogged, the engine slowly lost power. The machine communicated in the physical language of vibration and sound. But a computer does not tap, and a sensor does not shake. When an electronic component failed in a PowerTech engine, the machine did not communicate through sound. It communicated through a digital error code flashing on a dashboard screen. The engine might sound perfectly fine, but if the ECU determined that a sensor reading was out of the acceptable environmental range, the computer could instantly cut the fuel supply. The engine would suddenly go into limp mode, a protective state that drastically reduces power, allowing the tractor to barely crawl out of the field if it moved at all. This introduced a new kind of paralysis to the American harvest. If a tractor died in the middle of a Kansas wheat field in 1985, the farmer grabbed a toolbox, pulled apart the mechanical system, found the broken piece of iron, and fixed it. If a tractor went into limp mode in 2005, the farmer could stare at the engine block all day. But a wrench could not fix a corrupted digital handshake between a sensor and a circuit board. The breakdown of the engine had moved from the physical world into the software world, and that meant the balance of power between the farmer and the machine had permanently shifted. This was the quiet alteration of Force 2: dealers, fleets, farmers, and service networks. The local John Deere dealer was no longer just a place to buy a replacement gasket or a heavy steel part. The dealer now held a monopoly on the diagnostic software required to speak to the engine. If a tractor threw a critical code, the farmer could not clear it. They had to call the dealership and pay for a service truck to drive out to the farm, not to turn a wrench, but to plug an authorized laptop into a hidden port under the dashboard. The machine still belonged to the farmer on paper. The bank loan was still in the farmer's name, but the fundamental right to understand, diagnose, and command the engine had been outsourced to a piece of proprietary software. The electronic fuel injection was a quiet fracture, but the engine was about to be buried under an exhaust system that would take the tractor completely out of the farmer's hands. The true system collapse arrived with the final phase of the EPA's Tier 4 emission standards in the 2010s. The government mandate required diesel engines to achieve near-zero emissions of nitrogen oxides and particulate matter. To achieve this, the John Deere engine could no longer just burn fuel. It had to become a mobile, high-temperature chemical processing plant. The physical architecture of the engine was suddenly buried under a massive, complex exhaust after-treatment system. This system relied on two critical new technologies. The first was the diesel particulate filter, or DPF, a specialized filter in the exhaust system that captures soot from the burning diesel fuel. But a filter eventually fills up, so the engine's software periodically forces a regeneration cycle, dumping raw fuel into the exhaust to create extreme heat and burn the soot into ash. The second technology was selective catalytic reduction, which required the use of DF, diesel exhaust fluid, a urea-based liquid injected into the exhaust stream to break down harmful nitrogen oxides. These systems were incredibly effective at cleaning the air, but they were exceptionally fragile in the brutal, vibration-heavy, dust-choked reality of an American farm. The exhaust system was suddenly lined with delicate temperature sensors, pressure differentials, and NOx sensors. If a single wire on a DEF pump chafed against the tractor's frame, or if a particulate sensor failed due to intense heat, the engine's computer reacted immediately. It did not matter if the heavy iron block, the pistons, and the crankshaft were in perfect mechanical condition. The software would trigger a countdown, and the engine would automatically derate, slashing horsepower until the massive tractor could barely move. For the American farmer, the stakes of a breakdown had not changed. A delayed harvest still meant financial ruin, but the method of repair had been entirely stripped from their hands. If a Tier 4 John Deere tractor went into limp mode in a Nebraska cornfield, the farmer could not simply bypass the failed sensor to finish the day's work. The software was locked behind proprietary digital firewalls. The farmer was forced to park the machine and call the dealership, but the dealer network itself had changed. This was the era of Force 6 corporate consolidation. The local, family-owned John Deere dealerships that had defined rural towns in the 1970s and 1980s were rapidly disappearing. They were bought up by massive, multi-state dealership conglomerates. Dealer consolidation, the process where large corporate chains acquire independent local shops, meant that the farmer was no longer calling a neighbor who understood their specific crop cycle. They were calling a regional dispatch center, taking a number, and waiting in a service queue. When the service truck finally arrived, the technician did not pull out a wrench. They pulled out a ruggedized laptop, plugged it into the tractor's diagnostic port, and ran a proprietary software program to tell the engine it was allowed to run again. The farmer was charged hundreds of dollars for a service call that consisted entirely of clearing a digital code. The tension over this system erupted into a legal and cultural war. John Deere argued that modern tractors were incredibly complex and that allowing farmers to tamper with the engine control software could violate federal emissions laws or create safety hazards. In legal filings, the company invoked copyright law, effectively arguing that the farmer did not truly own the software that made the tractor run. They merely received an implied license to operate the vehicle for the life of the tractor. To a farmer whose family had rebuilt 40-120s and 4440s with their own hands in their own machine sheds, this was a profound betrayal. It sparked the national right to repair movement. Out of sheer desperation, a digital black market emerged across the Great Plains. Farmers began sourcing unauthorized diagnostic cables and cracked software, often imported from Eastern Europe, not to illegally boost horsepower, but simply to clear error codes and keep the harvest moving without waiting days for an authorized technician. The physical reality of the American farm had collided with the digital reality of modern manufacturing. The engine was no longer just a machine, it was a subscription. The parts were no longer just iron, they were intellectual property. The system that had once empowered the rural economy was now holding it hostage. The engine still ran. The iron was still heavy. The sensors failed. The software locked the block. The laptop replaced the wrench. The dealer network consolidated. The mechanical trust was broken. The iron remained in the fields, but the soul of the machine, the American farmer's absolute right to keep it running, had been permanently locked away. John Deere did not collapse. Unlike so many American industrial empires that were sold off, broken apart, moved overseas, or driven into bankruptcy, Deere and Company thrived in the digital age. Today, the Waterloo engine works, still produces massive, incredibly powerful diesel engines. The modern PowerTech blocks are marvels of thermodynamic efficiency. They produce immense horsepower, consume less fuel per acre, and emit exhaust that is often cleaner than the ambient air the tractor draws in. The company survived, the factories remained, and the green and yellow badge is still the dominant force in global agriculture. But the mechanical engine, the piece of iron that could be understood, diagnosed, and rebuilt by the person who owned it, was permanently replaced. This transition created one of the most unique preservation cultures in American industrial history. Usually, when a machine is rendered obsolete by new technology, it is relegated to a salvage yard, a swap meet, or a museum display. But the pre-emissions John Deere diesel engine did not retire. It became the center of a rural economic rebellion. Across the American Midwest, farm equipment auctions have become battlegrounds. When a well-maintained John Deere 4440, 4640, or a legendary 4020 rolls onto the auction block, the bidding is fierce, often driving the final sale price to double or triple what the tractor cost when it was brand new in the 1970s or 1980s. This is not nostalgia. An old 466 cubic inch diesel engine sitting under a faded green hood is a physical argument about ownership. When an American farmer pays a massive premium for a 40-year-old tractor, they are not buying a memory. They are buying a machine that operates entirely outside the modern, software-locked service network. They are buying an engine that has no diesel particulate filter to clog, no DEF pump to fail, and no engine control unit to suddenly derate the horsepower in the middle of a critical harvest. They are buying a mechanical platform that guarantees their independence. Because of this intense demand, a shadow service network has emerged to keep these older blocks alive. In independent machine shops across Nebraska, Iowa, and Kansas, the mechanical rebuild culture is thriving. Mechanics who left the massive corporate dealership conglomerates are making a living tearing down old 404 and 466 cubic inch engines. They pull the worn cast iron blocks into their bays, press in new wet cylinder liners, rebuild the mechanical fuel injection pumps on analog test stands, and flip through oil-stained, factory-issued service manuals that were printed 40 years ago. These working relics proved to be such a threat to the modern equipment model that they eventually triggered a legal reckoning. The frustration of farmers staring at locked engines sparked the national right to repair movement. The sight of older mechanical John Deere tractors commanding massive auction prices became a glaring piece of evidence in state legislatures. It proved that the American farmer still desperately wanted the ability to fix their own equipment. In recent years, under immense public and legislative pressure, the company and the broader industry have been forced to begin granting farmers and independent repair shops access to the diagnostic software, manuals, and tools required to clear codes and fix modern engines. The old iron literally forced the law to change. The progression of the American farm engine, From the rhythmic, heavy popping of the two-cylinder Model D, to the smooth, relentless torque of the 4020, to the turbocharged dominance of the 44 and 40, and finally to the locked digital systems of today, mirrors a broader shift in how America relates to its machinery. For nearly a century, American power was transparent. The engine was a physical partnership between the foundry that cast it, the dealer that supplied the parts, and the farmer who turned the wrench. That transparency built a rural middle class. It taught generations of Americans how to measure trust, not by what a company promised, but by how a machine sounded under a heavy load, and whether it could be repaired before the sun came up. America did not stop needing power. It simply stopped building engines that the owner was allowed to fully understand. We traded mechanical independence for digital efficiency, and in the process, a specific kind of American self-reliance was left behind. Somewhere in an American machine shed, an old John Deere 4440 sits quietly on a concrete floor, the heavy cast iron block ticking as it cools down after a long day in the dirt, waiting for a morning where it will start with the turn of a key, a puff of black smoke, and a mechanical sound that no software can ever replicate. See you in the next one.